Okay, so for the following circuit, we have to find VC, Vx, and Ix when time is greater than 0. But we're told that VC at 0 is 15 volts. So let's find an equation to represent VC. But first, we're gonna I'm gonna show you this. So to find for a circuit like this, for first order circuits like this, it's gonna be in this format. Wait, sorry. Okay, so this will be our voltage at time equals 0. So this one we already know it's going to be 15. But this is what I want to put my attention into. So this is called the time constant. It's equal to the Thevenin resistance times the capacitor value. Sorry, not Thevenin resistance. I mean the Thevenin equivalent. Sorry, the circuit, the resistance equivalent. Okay. So that means we have to find the resistance equivalence from the capacitor terminal. So between these 2 points, we have to find the resistance equivalent in there, and then we times it by the capacitor, and that will give you our time constant. And then we can use this formula to solve for Vt. So let's start by trying to find the Thevenin, the resistance equivalent. So let's redraw the circuit here. All right. First thing we see, we can add these two up. So 12 plus 8, that's 20. And this are in parallel because we can, since they're connected to the same node, we can bring them here. So it'll be 1 over 20 plus 1 over 5 to the power of minus 1. So it's 4. So the resistance equivalent is equal to 4 ohms. Now we times it by the capacitor, and the capacitor that we found the equivalent under was 0.1 fards. So it'll be 4 times 0.1. And this gives you 0.4 seconds. Okay, time constant is in seconds. And now we can solve for the formula for VC. So VO at 0. So this will be 0 seconds. So this is going to be our VC value at the very start. So VC 0, which was 15 volts. E to the power of t over the time constant, 0.4. So 1 divided by 0.4, that's 2.5. Okay? And so now let's solve for Vxt. To solve for Vxt, we can actually do, so we know at this region, this is what it's going to be 15 E minus 2.5 T volts. Okay? And if you know the voltage there, we can actually find the voltage here using voltage division. So we'll do 15 E minus 2.5 T. And if you recall voltage division in series, you take this resistor all over 8 plus 12. Okay? So the resistor you're trying to find, all over 8 plus 12. And let me see what that gives me. It gives me 9 e to the power of minus 2.5 t. Okay? Oh yeah, and for this, it'll be 8 over 8 plus 12 if it was in parallel. Okay, so just be careful of that. Since it's in series, it's 12 over 8.12. 8 plus 12. And finally, we have to find the formula for Ix. Ix is also very easy. We see it passes through the Vx. So it'll be Vx over 12. Okay, so it'll be 9 e minus 2.5 t over 12, and that's just 0.75. So Ix t will be 0.75 e minus 2.5 t. And those are your final answers.